In this lesson, we're going to go over graphing lines. Specifically, we'll understand the coordinate plane, we'll graph lines. We'll understand the slope-intercept form of a straight line. We'll graph a line given the slope and the y-intercept. We'll graph a line given a point and the slope, and then we'll learn how to find the slope from 2 points. First, the coordinate plane. So this is where we'll graph lines. The picture on the screen that you see is the coordinate plane. The coordinate plane is determined by 2 axes, the x-axis, which is the horizontal axis, and the y-axis, which is the vertical axis. You can think of these as 2 number lines put together in a way. So where the x and y axis cross is called the origin, and then as you go to the right horizontally, x values go 1, 2, 3, and so on. I'm not going to write too many because it would be very messy. As you go up in the positive y direction, 1, 2, 3, and then if you go to the left, -1, and so on, and as you go down, -1, and so on. So what that means is this is quadrant 1, where x is positive and y is positive. We have quadrant 2, where x is negative, y is positive. We have quadrant 3, where x is negative and y is negative. And we have quadrant 4, where x is positive and y is negative. Okay, so on the coordinate plane, we'll plot points and we'll graph lines. So one thing to note is parentheses x comma y close parentheses is an ordered pair. Ordered pairs must have parentheses around them. So let's say you were asked to plot the point -5, 3. So notice that -5 is in the x position, which means that you would start at the origin and go -5 in the x direction, and then you would go +3 in the y direction. Okay, so that first number is how you're going to move left, right. That second number is how you're going to move up, down, and that's where you will get the point that you're asked to plot. Okay, so starting off, so -5, so we start at the origin and we go 5 to the left. 1, 2, 3, 4, 5, and then since y is positive, we go up 3. 1, 2, 3. So this is the point, this one right here, -5, 3. Okay. So now that we've understood the coordinate plane, let's talk about slope-intercept form of a straight line. You may have seen y equals mx plus b. So m is the slope of the line. It's also called the rate of change. It's how much you rise and run to get from one point to the next, and that amount is constant. B is the y-intercept, so it's where the line crosses the y-axis. So to determine slope, let's say you have 2 ordered pairs denoted by x1, y1 and x2, y2. To find the slope, it's rise over run, or the change in the vertical distance to get from one point to the next, divided by the change in the horizontal distance to get from one point to the next. You could also think of it as y1 minus y2, x1 minus x2. Either way is okay, just make sure you're consistent. Second point minus first, or first point minus second, but either way you will get the right answer. B is the y-intercept, and so let me just sketch, well, that's a little hard to see, but where our line crosses the y-axis, so this would be the y-intercept. The x is 0 there, so you could also label this as an ordered pair of 0, b. Okay, so understanding slope, I'm just going to kind of talk about it conceptually. We won't actually calculate the slope of these lines here, but take a look. Slope can be thought of as the steepness of a line. So take a look at the first graph where, let's say you were going to get from one point to the next, you would have to go up in the positive y direction and over in the positive x direction, which means if you were to plug this into slope, you'd have a positive over positive. So this is an example of positive slope. For this next line, to get from one point to the next, to determine your slope or your rate of change, you have to go down, so negative in the y direction, and you're still running to the right. So you can think of this as fall and crawl if you want. So looking at our slope formula, we'd have a negative change vertically from the y values over positive, which would give us negative. So this is an example of negative slope. The third graph, to get from one point to the next, there's no vertical change, there's no change in y, which would be 0, and then you would run either to the right or left, but 0 over any number is 0. So this is an example of 0 slope. So horizontal lines, the slope is 0. For the next, that fourth line there, to go up, our vertical change would be positive. You could also go down you'll see what's going to happen. And then there's no change in x. So in this case, we divide by 0, so the slope is undefined. Let me write it smaller. So vertical lines have undefined slope. Okay, so there's a picture that might help. So let's say you're walking along a path. Let me draw, so you're going up a mountain. So as you're walking along, there's no effort. You've got 0 slope. As you go up, it's positive. As you go down, it's negative. And then if you try to scale a wall, unless you're somebody from the matrix, it's not going to work. So that's your undefined slope. So getting into our examples, graphing the line. So I think the computer software shows you how to plug in values for x to plot points, which is definitely one way to do it. I will show you another way using the slope and the y-intercept. So remember, the general form of a line is y equals mx plus b, the slope-intercept form of a line. So our slope in this case is the number in front of x. It's 3, or you'll see why in a minute. Remember, any whole number can be put over 1. So I tend to write my slope as fractions. B is 1, which is the point 0, 1. Okay, so this is where you start. So you'll plot this point, 0, 1, and then you'll use your slope to get to the next point. Since slope is positive, it means we're going to go up 3 from the first point we plotted over to the right 1. So from the y-intercept, so the y-intercept is your starting point. So don't do slope from the origin, do it from the y-intercept. We go up 1, 2, 3 over 1. And you could keep going. All you need is 2 points to make a line, but you could go up 1, 2, 3 over another one. And so that would be the equation, or that would be the line that corresponds to the equation y equals 3x plus 1. The next case, if you're asked to graph the line 3x plus 4y equals 12, notice it's not quite in the form y equals mx plus b, but in this case you could solve for y and get it into this form. So using what we did previously, we'll solve for y, which means we move x. Okay, so we have 4y is equal to negative 3x plus 12. And then to get rid of the 4, it's being multiplied by y. So divide, I recommend dividing each term by 4 so that your slope is easily identifiable as well as the y-intercept. So this is y is negative 3 over 4x plus 3. And then you do the same thing. We'll start at our y-intercept of 3. And then since our slope is negative in this case, we would go down in the y direction and run to the right 3. So we go down 1, 2, 3, and then we go over 1, 2, 3, 4. Okay, and then notice here, you can always check from a couple slides ago, if the slope is positive, the line goes up. If the slope is negative, the line goes down. And so in this case, since slope is negative, you can double check that the line is going down. Next, graph the line with slope -2 passing through the point 2, -4. So whenever you're given a point, like in this case, you're just given an ordered pair that's not necessarily the y-intercept, this is where you start. So we'll start at 2, -4, and then we will use the slope of -2. So I'm going to write m is -2, which is -2 over 1. Remember, I like to see my slope as a fraction. Okay, so we start at 2, -4, so 2 in the positive x direction, -4, 1, 2, 3, 4. So here's our starting point. And then you use the slope to get to the next point. So we'll go down 2 over 1. Next, graph the line with slope 3/4 and y-intercept -1. So in this case, we're given the y-intercept. It would be at -1. And then our slope is 3/4. Both are positive, so we go up and over. So 1, 2, 3, 1, 2, 3, 4. And that would be it for that line. Okay, and again, you can double check that you did it correctly by, if your slope is positive, your line should be going up. Next, we're going to talk about writing the equation of the line. So our goal when you're asked to get it into slope-intercept form is this y equals mx plus b. There's a couple of different cases. You could be given 2 points and you're able to find the slope and the y-intercept from that, or you could be given the slope and a point. So write an equation in slope-intercept form for the line with slope 4 and y-intercept -6. So our goal We're working with y equals mx plus b, and we'll have to fill in m and b. Y and x stay as part of the equation of the line. So in this case, we're given slope is 4, so m is 4, and y-intercept is -6. Okay, so you could write this as y equals 4x plus -6, or y equals 4x minus 6, and that would be the equation of the line. Next, write the equation of the line below. So in this case, you're given 2 points. When it's on a graph like this, if you can, pick out the y-intercept. We can see where the line crosses the y-axis. And then you're also able to determine slope by counting. So first, our line crosses the y-axis at -1. So that means that b is -1. To come up with the slope, you can find the ordered pairs and use the slope formula, which I'll show. You can also count from one point to the next, okay? So in this case, to get the change in y, we would go up 1, 2. Okay, so if we're building our slope, that would be 2, since we have to go up 2. And then we're going to go in the negative x direction, 1, 2, 3, 4, 5. So 2 over -5, which is the same as -2/5. Okay, so put this together. This would be y equals -2/5 x minus 1. If you wanted to use the slope formula, you would have to find the coordinates, or the ordered pairs. So this would be 0, -1, and this would be 5, -3. And then you could use your slope form of x, or y2 minus y1 over x2 minus x1, and so on. So this could look like 3 minus -1 over 5 minus 0, which again, you would get -2 over 5. So you can find the slope using either the graph and by counting, rise over run, or by using the way to find slope, change in y over change in x. Thank you for watching. If you have any questions, please feel free to reach out to me.